one more important property of waves is that they reflect. Whenever a wave reaches a boundary, all or part of it is reflected. There are two main ways that waves can be reflected. I'm going to look at waves on a string because they're easy to visualize, but this actually applies to all types of waves. So imagine we have a string that's tied to a fixed boundary like a wall, that this end of the string can't move. And you send a wave pulse traveling to the right. When that pulse reaches that fixed boundary at the wall, it inverts and then bounces off and goes in the other direction. Now another possibility is that you have the end of the string tied to, say, a ring that can slide over a pole. So this is a movable end. And when you send a pulse to this movable end, the end moves up, then it moves down, and it sends that reflected wave not inverted. So it's still upward. So it's fairly easy to visualize waves on strings doing this, but all kinds of waves reflect. Sound waves reflect. Sound waves bounce off walls and come back. Seismic waves can reflect. In the LA area, seismic waves can reflect off of mountains, which are usually more dense than the ground of the valley in between. Electromagnetic waves reflect, and we'll talk about that in Physics 7. So this is another one of the essential wave properties. And when waves reflect, like for instance sound waves, they can bounce back off a wall. There's a wall in front of me as I'm talking. I can hear a little bit of echo from that wall in front of me, of those waves bouncing back. And those reflected waves can interfere constructively or destructively with the waves coming from the original sound source. So the field of acoustics spends a lot of time considering what happens when you have reflections of waves that then interfere constructively or destructively with more waves that are still coming from the sound source.